Okay, we are going to do trinomial factoring. Good, Jacob, you got here just in time. We just started. I just gave a big long speech, so you can ask them if you want what it was about. All right, so watch, trinomial factoring. We're going to do the easiest version of it today, and then we're going to pump it up a little bit tomorrow, okay, and do a little bit more difficult. And you probably recognize this from Algebra 1 and from Algebra 2. Let's talk about this first. What if I had something like this, x plus 3 times x plus 5. Remember with that other factoring we did with the grouping and the greatest common factor factoring? We said it's kind of like backwards of the distributive property or backwards of multiplication, and that's kind of what we're going to do here. So watch, I'm going to start off doing a multiplication problem, then we're going to look at the answer, and then we want to take that answer and go back to what we started with. Remember doing that with the GCF, the greatest common factor? Yeah. So let's do this real quick. You know how to do this, right? This is FOIL method, or just distributive property, so it's just x squared plus 5x plus 3x, which is plus 8x, and then plus 15. All right, that's not what we're really doing today. What we're doing today is we're taking this, okay, and we want to come to this. All right, so basically it would look like this. I'll keep this up there just so you see it. But basically, I'm going to give you a problem that looks like this. I'm going to give you the same problem. And it's going to say to factor. Might say factor completely, but that's what it means, okay? Just a factor. So what we need to do, we have to look at this and say, oh, this is a trinomial. That's why it's called trinomial factoring. You got an x squared, an x, and a number. Do you see that? So when you have an x squared, an x, and a number, a lot of times, not every time, but a lot of times, especially ones that they rig for you, you can actually start off with this as your question and then come up and say what times what is going to equal this stuff right here. That's what we do in factor, isn't it? We're trying to find what things multiply together to get this answer. That's what factoring means. So now this is in your brain right here. So that's your brain, okay? So let's not look up here just yet. I'll tell you what. Watch this. And let's fill that with white. There we go. So no cheating. All right. So look. Now you probably already written it down, but that's okay. What we do is we start off with this. And you say, oh, this is one of those trinomial deals. All right. So what did it look like? What was being multiplied to get to this? Well, it was two sets of parentheses, wasn't it? It was basically a FOIL method, right, in order to get to this answer. So that's the first thing I'm going to do. I'm going to put two sets of parentheses down because I recognize what this kind of problem looks like. I recognize it's a trinomial, and I'm like, oh, okay. When I multiply them together, I got two sets of parentheses that multiply together to become this. Does that make sense? Now, let's take a look. Let's think FOIL method. Some people call this backwards FOIL method, all right? If you want to call it that way, you can. This times this has to equal x squared. So what's going to go here? Yeah, x is going to go here, and x is going to go here. Is that familiar to you from Algebra 1 and Algebra 2? Yeah, okay. And then, forget the middle one for right now. Just look at the end ones, right? It's first, outside, inside, last, right? So let's just take a look at the last. This last one times this last one has got to equal 15. All right, and watch. You're right. So there's a couple things that add up to 15. Oh, there's 15 times 1, and there's 3 times 5, isn't there? All right. So do we use 15 and 1? Well, remember, outside, inside. So if I take the outside ones, these two, and the inside ones, these two right here, they have to add up to be this middle one. Do you hear what I'm saying? So we have to think of some numbers. This is where it takes a little thought. After you get used to these and you get good at these, it gets a little faster. At first, you got to think a little bit. This times this has to be 15. And the same two numbers that I'm going to put here and here have to add up to be an 8. So is it going to be 15 and 1, or is it going to be 5 and 3? It's going to be 5 and 3. So 5 and 3. Now, are they positive or are they negative, or is one the other? They're both going to be positive because positive 5 times positive 3 is positive 15. And when you add them together, you get a positive 8. So they're both plus. Does this work? Sure it does, because look, x squared plus 3x plus 5x is what? 8x. Plus 5 times 3 is 15. And then there you go. So what's our answer? Our answer is this right here. Didn't change that fill. There we go. Let's try that one more time. There we go. That's our answer. When it says to factor it, it's factored. These are the two things that are being multiplied together to get this answer right here. You see it? It's kind of like backwards FOIL method. A lot of people like to say. Now watch, let's take this off of here. And sure enough, that's the exact same thing as what we got, isn't it? Alright? So what I want you to do, I want you to do this. This one's a little bit tougher because you got a minus in here this time. And you got a big old number, but that big old number shouldn't be that big of a deal. I want you to factor. It's all under factor. I want you to factor this. So go ahead and do it. I'll give you a minute. Okay, let's take a look at it. We got, you know, this times this has to be x squared, so that's going to be an x. That's going to be an x. Now, forget the numbers right now. Let's just take a look at the signs. I should have done that up here. Just look at the signs. This number times this one's got to be a negative 63. So what does that tell you about the signs? That's right. One's positive and one's negative. It doesn't matter which one you put. Okay, you can put the negative here or the positive here, but one has to be positive and one has to be negative. Does that make sense to you? Yeah, absolutely. Now, this times this has to be 63. All right, now there's a bunch of things that become 63, but what multiplies to be 63, and then the same two numbers will add up to be a negative 2? 9 and 7. Now think about where's the 9 going to go and where's the 7 going to go. Do we put the 9 here with the positive? Because if we did, and we added those up, we'd get a positive 2, wouldn't we? All right, so we can't put the 9 here. Where do we put the 9? Right here. And we put the 7 right there. So let's see. Does it multiply to be negative 63? Absolutely. Does it add up to be a negative 2? Yes, it does. It's important, isn't it, where the 9 goes. The 9 has to go with the minus. The 7 has to go with the positive. I could have said x minus 9 first and then x plus 7 second. That'd be the exact same thing. That wouldn't make any difference, would it? Okay? Does that make any sense? Let's do one more. Okay, factor that one. Go ahead. All right, made a mistake. That doesn't work. Let's change this to a 4. I was looking at it. I was like, that is not going to work. All right, so let's try that one. That might be a little bit better for you. Do it real quick before you go. So I've got an x and an x. Now watch this. Let's think of the signs first. Don't even put any numbers in here yet. Just think of the signs. It has to multiply to be positive, but it has to add up to be a negative. So are they both going to be plus? They have to both be negatives. What are you going to put here? Are you going to go 2 and 2? No, because that won't give you negative 5. What are you going to put? 4 and 1. And there it is. Can you do those? Why does that keep going like that? Are we good with that? Okay.
Casey Murray.
Nope, hang on to them because we still got to go through some more on that. All right, let me give you a worksheet and then you guys can go.
John Hamrick.